And we're back. Hello, everyone. Welcome to Howdy Partner. This is a show where we like to highlight a lot of the cool things that our partners are doing with AWS. And today we have a special guest, but he's not new to the show. We have Lee from Pulumi. Lee, welcome again.
Hey, thanks for having me back.
Yeah, absolutely. And so before we get started, for maybe the folks that aren't as familiar with the show, or maybe this is your first time joining the stream, my name's Andrew Park. I'm a partner solutions architect with AWS, and I like to work with partners like Pulumi in building different integration points with the AWS ecosystem. And with me, I have my colleague Young, and I'll let him introduce himself as well.
Yeah, hello everyone. My name is Young Jung. I am also a partner solutions architect here at AWS. Happy to be here to highlight our wonderful partner, Pulumi, who is a repeat guest of sorts.
The three-peat, yes.
Three-peat, excuse me. So glad to have you on board. Will be a great session, I'd assume. And just glad to be here to highlight what Pulumi does.
And Lee,
yeah, looking forward to going through some new scenarios that we haven't gotten through before with you guys. So yeah, looking forward to a fun show.
Yeah, and I think what people love about the last two episodes that you're on is I think they really enjoyed watching the live coding, whether it was just watching you struggle and trolling you, or whether it was just like an actually informative like learning experience. I think people really enjoyed that. So again, like super glad to have you back on because again, like I think people really enjoyed that aspect of the last two episodes.
Yeah, and this time we're gonna do all live as well. There's literally zero, there's no smoke and mirrors. Everything is gonna be live. Like I have no pre-prepared samples or anything like that. So we'll see how it goes. Probably get a lot of flack from folks watching, like, oh, what is this guy doing? But yeah, we'll see how far we get.
Well, see, I think, for people trying to understand the difference between a live coding session and a demo, like this is literally like the bar. So if you guys ever want advice on how to go about doing this, like you're in the right place. But other than that, let's introduce today's topic because I think it's an exciting one. So on May 18th, AWS launched a new service called AWS App Runner. And so this is basically a fully managed way of deploying your web applications using serverless containers. And so I could not say that more literal enough. Like it is actually the easiest way to deploy your applications using serverless containers. You literally have a single pane of glass to where you can configure your load balancers, health checks, security, and everything. And the best part about it is you don't actually have to manage anything because you define everything straight from App Runner itself. And so that's what we'll be talking about today. We'll be going into Pulumi, talking a little bit more about their automation APIs. And during Lee's demo, he will actually show us how to deploy an application using AWS App Runner using Pulumi. So yeah, lots of stuff to cover today. But with that said, just to give some more context for maybe the folks that aren't as familiar with AWS App Runner and kind of how it works, or even like how it looks in the console, Young actually has a demo for us just to give an idea of what App Runner is and what it looks like. And then from there, we'll let Lee take over and do a live coding session. So Young, I'll let you take it away.
Yeah, so like Andrew mentioned, App Runner was launched or went GA last week. So it's still fresh on everyone's mind, certainly myself. So I've been playing around with it ever since it's been on. So let me show you how it works. And bear with me 1 second here as I share my screen. So this is the console of an App Runner service. I have this app that I use to kind of create simple Flask app. It was one of my data science projects. Just wanted to kind of build something that had a recommender system for where you want to travel. And the cool thing about App Runner is that you can upload it and you can deploy it really easily, whether it's through your repo or through a containerized image. So let me know if the fonts are okay. But I'm going to go ahead and create a service. And I've already containerized my application and uploaded it to ECR. Now, there's many ways to do that first step, but let's just assume that it's already on ECR. I'm going to browse into my repository. It's called Travel Recommender App. And as you can tell, it's pretty easy in the sense that, it's basically just a few clicks of a button to get everything set up. Here, you could either select manual or automatic. It depends on, how you're updating your container image. And you can choose to create a new service role. Just call in something random. And here we create a service name. So let's just call it Howdy Partner App Runner. And you assign virtual CPU and memory. I'm going to leave everything as prescripted. And my Flask app, as many Flask apps do by default, uses port 5000. So it'll point to port 5000. And there are other things that you can kind of configure. I'm going to leave everything as default, but you can certainly customize your own configuration based on what you kind of want to see in terms of auto scaling, health check, security, and if you want to add more text. So we click next. It's sort of a review of everything that you've checked, and that's as simple as that. You just create and deploy. Looks like we have an error. Error in assuming. Let's see. Let's go back.
You might just have to use your old role, the first one you created.
Yeah, I may just have to go back. This is the beauty of, I guess, live demo is that I make mistakes just like everyone else. No, that was the previous mistake. So it should, oh yeah, it already exists. I'm sorry. So I can't create a role that already exists. Instead, I'm just going to use the existing role. Hopefully it will deploy this time around. Yep. So it takes a bit of a time to get everything deployed, but you can, I guess another thing I can show you is that you can kind of check the logs as they go. So the event log itself, and then as the application's logging its status, you can also check the application logs. Obviously, you have to wait for it to be created to see any kind of logs. But it is integrated with CloudWatch, so you can always take a look at those logs in CloudWatch. But to make it easier for all of us, I've actually deployed it already in a service called sample app/ECR. So it comes with a default domain. You could always set up a custom domain, but all it took was just a few clicks of a button, some settings there, and voila, you have your app. And this is basically how easy it is to deploy a containerized imageable application using App Runner. But having said that, obviously we have Pulumi here today to show us another, I think, more interesting and perhaps more efficient way of deploying your application through App Runner and then kind of managing through it. So with that, I will leave it to Lee to sort of kick us off.
Sure, awesome. Thanks, Young. Yeah, so I think actually I saw someone asked on the chat kind of, is it counterproductive to use IAC for clicky application setup focused on simplicity? And it really, I think, it comes down to what you really want to do and what you're trying to get out of your infrastructure, right? In the case that we're about to show, or the way I think about it is that there's a lot of moving parts actually beyond App Runner. Like App Runner makes the application deployment part super easy, which is great because, it went from being before you had to set up ECS and Fargate and understand, a lot of those concepts to just understanding one concept, which is an App Runner service, which is great. But at the same time, there's a number of things kind of that surround that, right? For example, like where does your container image come from? How does that container image get built? How does it get uploaded? How do you set up that service role that we just looked at? And then kind of as your application gets more and more expansive, like, it's going to have persistent state, for example, it's going to have a database, it's going to have, a front end, potentially that's separate. And how do you manage all those things and tie them all together? That's where a solution like Pulumi makes a ton of sense, where you'd want to manage all of that in code and be able to understand how all those things are actually connected together. Cool. So I don't know if I don't know if you guys want to chat more about Pulumi, or if we should just start
Yeah.
recording stuff, or what do you want to do?
I think so. I think the last time we had you on the show, since then, you guys have released a lot of new features and capabilities through Pulumi.
Yeah.
And so I think maybe for the folks that aren't as familiar with Pulumi, can we just do like a quick, like 2 to 3 minute intro on like what Pulumi is, kind of what you guys focus on, things like that?
Sure. Yeah, I'll briefly describe what we do, and then also talk a little bit about some of the new things we launched in 3.0. So Pulumi, we just launched our version 3.0 on April 20th, actually. Shout out to, I guess, Elon Musk or something like that. But anyways, we focus on modern infrastructure as code, and the whole idea here is that we want to take software engineering practices and bring it to infrastructure as code. And so to be able to use all the software engineering practices you know and love, whether it's unit testing, CI/CD, the existing software tools you use in terms of IDEs, just everything around the software engineering ecosystem, you can still tie into your infrastructure as code. And Pulumi provides that interface to using infrastructure as code via programming languages. And so we support Node, Python, .NET, and Go as the language interfaces for using Pulumi. And so you can provision infrastructure with Pulumi. You can actually do a lot of stuff. Some of the new stuff we introduced in 3.0 actually takes those capabilities and takes it kind of to the next level. We GA'd what we call Automation API. And Automation API lets you use Pulumi in a more programmatic way. So as opposed to having to invoke the CLI and run Pulumi up, you can actually embed Pulumi as a library within any application you want, and use it just as a software library. So for example, instead of having to have this CLI-driven way of doing things, you could, as an example, build a website that lets someone deploy their own website off of your website. So it's kind of like, I don't know, maybe websiteception, but what they can do is come in, fill out a form and then click deploy. And what that's going to do under the hood is invoke, Pulumi Automation API, and actually then create state and go through all the various things that you would be doing in the CLI, but kind of in a, again, programmatic way, as opposed to kind of being CLI driven. We also GA'd our support for native providers. In this case, we had a preview of the Google native provider, then also we GA'd our Azure native provider. So I should mention Pulumi is works with multiple cloud providers, including AWS, obviously. And so we kind of added support that basically for, in the case of Azure, directly mirrors the ARM surface API, the ARM API surface area. I won't talk too much about that since obviously I think most of the audience here is interested in AWS. And then we also introduced a preview of our multi-language components. And that is a foundational technology for us where you can author your component in one language, whether it's Go or TypeScript or whatever it is, and have it available in all of the Pulumi languages. And so basically you author once, but it's available to all consumers in all of the languages that we support. And so actually the Pulumi EKS library is now built like this. So if you go and use previously the Pulumi EKS library, which was a convenience library that made it easier to work with EKS, was only available in TypeScript. With this new multi-language support capability, we took that technology we built, applied it to our own EKS library, and now you can consume that EKS library from Python, .NET, and Go. You can also obviously do this yourself, where if you have a Pulumi component or Pulumi package you've written, you can actually make it into a multi-language component as well, and make it available for consumption in the other languages. So yeah, those are some of the cool new things we really featured in our recent launch.
Solid. And then earlier you mentioned Elon Musk. And so when I think of Elon Musk, I think of a handful of different things. But I think the two things that I initially think of are Dogecoin and going to the moon. And so I know not too long after the second time you came on the show, I came across one of your blogs. I think it was regarding Pulumi Interstellar. I thought that was really interesting. Can you talk a little bit about that?
That was our April Fool's blog post.
Oh, was that the April Fool's?
Yeah.
Just for people that maybe aren't as familiar, I'm gonna post this because I thought this is hilarious.
So I wonder if I guess April Fool's, I guess.
It fooled me. I'll tell you that. Because I was reading this blog and I was like, "What is going on here? Like, what in the world?"
Fooled you, yeah. I guess you might not have noticed. Yeah, the published date on that was April 1. So it was April.
Well, on a first look, there is no publishing date, so maybe that's why Andrew was fooled there.
Yeah, I
I
definitely
think
was fooled. I was like, wow,
it might
this
be
is.
the very end. Yeah.
But no worries. Definitely fooled me there. But other than that, no, that's really cool to hear about all the different things that you're adding to Pulumi, especially with the launch of Pulumi 3.0. Other than that, I think that's a pretty good overview of Pulumi, and I think that gives people a good starting place for kind of the next things that we'll talk about in today's show. So other than that, Lee, talk to us about your live coding session and kind of what we're going to focus on.
Yeah, so I guess we can probably bring up my screen, and what we're going to do is start from literally a blank slate here with the Howdy Partner, and we're going to try to build a web application. But the way I'm thinking about it right now is like maybe I'll just bring up a text editor, kind of do it in multiple parts. So part one is going to be like get a Pulumi project going, right? And as part of that, we're going to build a backend that's like via a containerized app runner service. And we'll do this in Python Flask, I guess. And then next, after that, we will build a front end. And there we'll probably use React and TypeScript. And then after that, hopefully, if we have time, we'll tie the two together via Automation API. And kind of show how you can kind of orchestrate your various Pulumi stacks together using Automation API. So we'll see how far we get. I'm sure I'll make lots of mistakes doing this, and yeah, let's do it. So let's start in my terminal, and we'll make. Okay, that's not a good start. And we'll make the first project the back end. And so we'll do Pulumi new AWS Python. And so what's going to happen here is we're going to create a new project called backend, and I'll just give it the default description, give it the default stack. And so, oh, by the way, I guess not everyone here is probably familiar with the concept of what's a Pulumi project and what's a Pulumi stack. Let me finish putting that in, and this will create a bunch of stuff. But a Pulumi project is, you can think of it as like that's the Pulumi application, that's the code. And a Pulumi stack is a set of configuration that feeds into that code for a specific environment. So for like a common paradigm you might see is like, I have a project. I'm going to define my code in this project, but then the actual, like, for example, the region, for example, here is defined in my config, and you can imagine having like another stack called Pulumi prod. You call it the prod stack, and the prod stack might deploy to a different region, for example, or to a different account, or whatever other configuration you want to pass in from that perspective. So. Yeah, so what's happening at the very beginning here, after we did this Pulumi new thing, is we actually automatically create a virtual environment, install all the dependencies that you need as part of that virtual environment, and now it's ready to go. One thing I just noticed is, oh yeah, this looks good. So if we run, if we go in here, you can see this is a very super simple project where this looks like Python code you'd expect. You import the libraries, and then you instantiate a bucket resource, and you can export. So we can actually just run this, Pulumi up. Oh, and by the way, earlier before the show, I had AWS SSO logged in. We use SSO here at Pulumi, so my credentials should be available to the AWS provider, and that should make it possible for me to talk to AWS. So hopefully that all works. Actually, don't know. I didn't test it earlier. Actually, I should have done that, but we'll see. So okay, so we say yes, and that should create a bucket for us, and we can open this up. This will show us the. Oops. And so you can see here, this is, you can even follow along the live update in the console, in the Pulumi console, for example. And looks like it actually finished already. So you can see it created this bucket resource. And if I go to the resources tab, you can even open this up in the console. And it'll direct you just to directly to that bucket. And one thing to note here is like there's this random hex stuff afterward. And in Pulumi, we do this thing called auto naming, where when you create a resource without providing the name, you can see here I didn't provide it a. Oops, let me open this up actually. I think the auto completion is not working because I'm not using the right. It's not detecting that. Hopefully this brings up the auto completion. There we go.
Oh, there it is.
And so here, if I gave it, oops, not ARN, if I gave it bucket, then that would be a specific name. But since I didn't give it, the name here is kind of like, there's two names in Pulumi. There's this is the logical name within the program. And there's also the actual physical name of the resource. So the physical name of the resource is my bucket, whatever. And the logical name is, in our program, it's just my bucket. And so if you don't specify an exact physical name by, doing something like, foo, then what will happen is we'll take the logical name and then append something to it to basically make an auto-named thing. And that's actually really nice if you think about how this works, because what this lets you do is, not in the case of buckets necessarily, but in the case of, like, say, an instance, if you ever have to replace the instance, we can kind of do Pulumi by default does creates before any deletes. So we'll create the new instance with a different name because it's auto-named. It'll have a different hex suffix, and then it'll tear down the old one at the very end. And so kind of there's a nice kind of availability pattern here that happens. So anyway, okay, so we don't actually want this. So we can delete all that. We don't need a bucket, for example. And let me pop up in the terminal again. And we can Pulumi up, and we have an empty program. But what this should do is this should actually remove that bucket, since it's no longer defined in our application code. So okay, so this is all very boring. Let's actually. Oh, I didn't run yes. Okay, so now let's. I actually have never built a Flask app, but I thought I would use two languages. So this is going to be interesting. Yes. So we're gonna. I found this tutorial right before we started, and we're gonna try to do. We're not gonna do exactly this because we don't actually want to use Lightsail, but we're gonna try to do something along these lines to see what we do, to see how far we can get. So all right, let's try it. So okay, this looks like good.
Standard Flask. Yeah.
Yeah, this looks like standard. So we're gonna make a new directory here called app. And I guess, does this even say what this goes into? Does this go into let's see. App.py? Okay. Let's try that. Okay. And we'll add a requirements file. So we're building our application here, our little Flask application. And we're gonna build this into a container image, and then we're gonna use this Pulumi program to deploy that container image. So that's what we're trying to do here. So let's try this, and then okay, really just copy and pasting stuff to see if this works. Which, yes, it won't be embarrassing for me if it doesn't work, since it's your guys'
fingers crossed.
So
in theory.
All right, let's try this. Let's see if this works. Oh, am I not running? Oh, I must have quit Docker by accident now.
And I guess a lot of the audience are suggesting different languages like Golang or Node instead of Python.
Oh.
Just as a suggestion.
Yeah, well, I think we kind of went down this path already. So we'll do like I mentioned actually at the very beginning when we did this outline. We will switch to TypeScript after this, after we get this part running. Okay, so my Docker daemon actually is running. I don't know how I think I restarted. Come on, I restarted my machine earlier today for this Mac OS update, and somehow that seems to have decided to. I don't know why that meant Docker Desktop wasn't running as a result, but that's what that meant. All right, come on. All right, here we go. All right, expect this to work.
Nice.
And I expect this to do the right thing, but let's just keep following along for now. Let's make sure this works. Because I mean, we're actually very close to having this run in the cloud in a second here after this this is all done. So let's see, make sure this works. Okay, great. So
we're off to a great start.
All right, so far so good. I haven't completely failed yet, and we're like 10 minutes in, so that's pretty good. So now we can skip this part because we actually have all we need. So now what we're going to do is we have this app, and we can actually come in here and let's add this to our requirements. We're going to use Pulumi Docker. I think this is the right version number. Let's check. Actually, I'll just pip install it. So we can just, again, we can use, where am I? Pulumi Docker. Because, yeah, this 3.0. So we can, just install packages like this. And so now we have Pulumi Docker. And so I can import Pulumi Docker. So you get all the nice completion. So, okay, so what we're going to do now is we're going to create an ECR repository because we want to actually host our image, right? So let's do that, and let's get rid of this. So let's see, repo equals, and we want to create a repository, and you can see we get the nice completion. So we're going to call this, I'm going to use double quotes because that's what I'm used to. We'll call this backend app. And I don't think it actually needs anything else in terms of we don't need any of this other stuff. We don't need encryption configuration. I don't think I need any of this. So I'm just going to skip all that. And we just have this repo. And now what we're going to do is we want to actually stick this image into that repo. And so that's what this Docker thing is for. And this, we'll call this app. Actually, we can call this backend app as well because it's a different. Even though they're named the same, these are different types, so it's acceptable to do that. The image name, and so the image name needs to match the repo's name. And so we can actually just use that here. And the build here is going to refer to the actual Docker build we want to do. And I believe this should be the context. So this should be app, right? In this case, because we're going to do that. We're going to do that build,
right?
And I think the last thing we need to do here is you can see we have name, build. And we also need this registry information. So we're going to put that into registry. And this is and this takes a username and password, which a server username and password. And so there, we're going to get that from ECR. And let me just tidy up my code a little bit here. Okay, so to get that, we need to call ECR creds get. I think it's get credit. I think it's get this one. Let me see. What does this get back? Password, and yeah, it has a username and password. Okay, great. Let me actually look something up because I don't remember which. Oh, I see. Right. Okay. Yeah, this is right. Okay, cool. So let's do this. So, okay, so now we can fill this stuff in. So we had server, and the server is going to be the actual URL of the server we're trying to shove this image into. So it should be the repo's URL, repository URL. By the way, if you're ever like, what is this stuff? You can all this is hoverable, so you can be like, oh, the URL of the repository. So that all this is nicely documented. Or you can also just go look at the Pulumi docs on Pulumi.com. Okay, so now we need the username, and this is going to come from our creds username, and we have a password. Oops. Okay, and that should work. Let's try this. This will be the real test of how good my live coding skills are, because so what have we done so far is we have created a repository. We've obtained the credentials from ECR for accessing Elastic Container registry. And then we're going to try to take this image that we're going to build off of this directory here and give it the right credentials, and then hopefully it'll make its way into the repository. So let's see what happens.
Cool.
Let me see if there's any questions so far. Yeah,
let's see if there's any questions. Let's see. I think the first one I see is, what about compliance as code? And I think we talked about this a little bit the last time you were on the show. So I'm gonna take a guess at this, but I think he's just asking, can you do compliance as code with Pulumi?
Yeah, you can. There is a feature in Pulumi called policy as code, and basically that lets you write code, and it checks your resources against that code to see whether or not those are compliant. Oh, request access to the resources denied. Interesting. Let's see. Docker push failed. Huh. I wonder if I have the wrong information in here somehow. I don't think so. Username, password. That all looks correct. Oh, I see. Okay. So this is where I mistakenly put in the wrong parameter here. This, I think what's happening is, the second argument is image name, but the image name is not the repo's name. Because the repo's name is backend app dash whatever. This should actually be the repository URL. I think should be the. I don't know what's going on. I feel like this happens when I live demo.
Nice. I like one of the comments I see in the chat. When in doubt, brute force it.
Right, yeah, right, exactly. No, because earlier, I think if I scrolled back, I think I saw, you can see here it was naming to, you can see it was assuming this, as opposed to, you can see here, this is the correct name that we actually want, the fully qualified name here. So that was the difference between, that's kind of what hinted me at earlier when I saw this. I was kind of like, they probably screwed up the name here. But now that we're looking at this looks like what we actually want, which is the actual repo. So, okay. Great, that actually worked. So you can see it removed the old output. We got rid of that from the code, and it's actually pushed the image to the repo. So we can actually check that. If we go here, you can see this update succeeded. Under resources, I have a repository. Let's go look at the repository. And, oh, did I mix something up? That's weird. I was just, I wonder if the URL is just slightly off. Okay, it is there. And then this was pushed 1 minute ago. So great. Okay, so this is the actual image. So now we have the image in the repo. Let's actually stick it into AppRunner. So now we need to actually define. So in the demo that Young had, he created a role for App Runner to be able to pull from a repo. And so we need to do the same thing here. So we'll call this App Runner role. I don't know what to call this. Let's call it this. And then this role needs to have a policy. And this is where I'm going to cheat and look up what I think should be the policy. Let me just pull this up. So here, I'll show you how I'm cheating, by the way.
Is it cheating though? I feel like it's pretty realistic.
Yeah, this is. I feel like this is a day in the life of a.
So far, this is Where I'm cheating, I guess, is I'm going to go to the. I wrote a blog post recently on doing this. Well, you can see I did this in Go, by the way. So this is where it's slightly not cheating, but like I'm just going to crib off these policies because I don't want to remember how to write IAM policies here.
See, I definitely don't think it's cheating if you're looking at your own blog.
Something that you wrote.
Yeah. Well, the thing is, like I said I was going to do this all completely live code, and I mean, we are still live coding, but it's like I'm using code I know should hopefully work. Okay. Anyways, all jokes aside. So we'll call this the assume. We need to have the assume role policy, so obviously ECR can access it. And so that's just actually, how does this work in the Python SDK? I think it's I think I need to import. Yeah, we're going to JSON.dumps so that basically this will serialize this object to JSON formatted string. So that's what we want. And we're going to have this object, and we're going to. Yeah, this is obviously not exactly correct, but this is going to be close. And here, and service is this. Okay, I think that should be correct. So you can see we've just defined this policy, and then we're going to also create this pull policy. So it's kind of interesting to think about kind of like how these are very similar between the languages, actually, how these things work, but just slightly different syntax, obviously, since we're using Python here. Okay. And then obviously we need to actually give it the, oh yeah, I forgot this part. So let's back up here. Let's do this. This needs to give it a assume role policy, and that is equal to this ECR assume role. Should name this policy actually. Okay, so this is going to let App Runner actually assume this role that we're about to create, and then we're going to attach this to that role. So again, cribbing off the previous code I had, we're going to basically do this. Oh, this is actually like not the cleanest way to do it, so I'm going to not do that. It's better to use a role policy attachment. And so here we give it the policy yarn and the actual role name. So we can do role. Oh, what was it called? Oh, App Runner role. I think this should be the, I think I just, and then the other one was policy yarn. And, oh, we actually never made this to a policy, so we should do call this image. All right. Okay, so we have that. We attach that policy, and this is called the image pull policy. Oh. Yeah, that should be the arm of that. Okay, great. Cool. So let's try running Pulumi up, make sure we have all those things correct.
So while this is running, I just want to call something out. I think in all my time I've been in tech and just working with AWS, I kid you not, there's only one person I've ever seen that's been able to write like IAM policies from scratch without having to look up documentation or anything else like that. And so, yeah, that's definitely not cheating. Like, if you were to do this all from scratch and from memory, like I would be extremely impressed because IAM policies from scratch are not like the easiest thing to write.
Who was it?
Her name is Becky Weiss, and she's
I know Becky,
senior principal engineer. Yeah. That like when I saw it in person, like that was insanely impressed.
Oh, okay, unhashable type. I wonder if I made a statement. Oh, do I have an extra brace here? It looks like I do. How did I do that? Okay, that's weird. Did I do that up here too? Oh, I did. I think I must have been when I was copying over the Go stuff that I must have introduced that by accident. So let's try that again. Yeah, Becky, and actually, I don't know if you know Graham probably can write IAM policy without ever looking at the docs either.
Yeah, I'm gonna be honest. Every time I have to write one, I'm always looking at documentation. So yeah, I'll be 100% honest there.
Okay, and it looks like now we got the.
Nice.
Oh no, there's another error.
Oh.
Let's see. Try to unpack non-iterable policy object. Where did I do that? On this line. Let's do this.
I think you might have an extra comma in there.
I'm just gonna real quick look at like an example of doing this in Python. Okay, I did this. Did I not do this? Oh, a statement should be. Oh, is a statement? Did I mess this up? Should this be an array? It looks like from the example. I see. Okay, I guess that might be it. Otherwise, it looks like I have the same thing, right?
Oh yeah, because you can have multiple.
Yeah.
Events.
Okay. Let me try that. I wonder if this is going to be wrong too. Then.
Yeah.
Let me go back and look at the role examples.
Yep.
Okay, so I probably should do that as well. Otherwise, I think I have this. Maybe this is correct. Let me just control C this. I'm just gonna -- yes as well, instead of just skip the preview. I think that's, yeah, let me just, while we're waiting for that, let me just double check this. Okay, yeah.
I guess while we're waiting, if anyone's joining right now, we're on another episode of Howdy Partner. We have Pulumi and Lee from Pulumi with us for the third time. Today he's showing us this cool demo to create an application, a Flask app into an image, pushing it up to ECR, and then we are in the process of creating an app runner service, which
yeah, it still happened. Line 32.
and we are sort of stuck with creating the policy.
What am I doing wrong here? I am policy. I don't know. It looks like I got.
Yeah, there's a comma after the.
Yeah,
name.
I thought that this is allowed in the syntax, but maybe.
Doesn't
Like you can see
appear
here,
on
like
the-
I thought it.
No,
I thought
no,
it.
no.
TypeScript, I thought
When
you
you
were allowed
go
to do this.
when you go to the very beginning, the very top, where it says image pull policy, comma, maybe that comma some sort. Either.
Oh no, you need this because this is the
No,
this is
not
the
that one.
clear argument here.
The first comma on
sorry.
the first comma on
here.
the,
Oh, yes.
Oh,
yes.
is that a comma? I thought that was a.
I totally didn't even see that. That is totally a straight comma. Yes, thank you. That yes, that would explain that error message as well.
hopefully, if that didn't
yeah,
fix
with the comma, it was probably expecting to destructure the result of this, which is like this is just a single object. It's not iterable. So that makes the error message makes total sense. Yes, you're correct. Yeah, because the error message we were getting was cannot unpack non-iterable policy. Like this policy object is not iterable and cannot be unpacked into like, two variables. And yes, okay, great.
I feel accomplished. I have contributed to today.
So assuming this works, what we're going to do next is, I think after this, all we have to do is create the app runner service. So and so we're going to give this to the service. We're going to give it a here. I'm just going to steal this example here. Oh wait, we don't want exactly that example, but okay. So we have the service name. Oops. And then what else do we need? We need the.
And it looks like it was able to deploy successfully.
Right. Thanks. Yep. We need the. Oh, I thought there was is it source configuration, I guess? Let me go back to the docs, actually. But I don't want this. The other, here we go. Oh, it is still called source configuration. Okay. Well, let's. I don't think using documentation is cheating.
Oh, not at all.
So I would hope not. That I feel like if that were then like we would be all doomed as developers. Okay, so but the difference here is we know from earlier that I think we had defined the app to run on port 5000.
Yeah, 5000. Yeah.
So we're going to define that here. And then we also know here that this actually is going to refer to the image we built, which is repo image. And we will use the, I guess there should be the image name. I think that should give us the correct thing. And and this is not ECR public, but this is ECR private, I assume is the other possible value for this. It doesn't say in the docs. But I'm just going to assume that's true. Just double check while that runs. App runner ECR public private. This doesn't tell us. Maybe in here. Do you happen to know?
I'm
Maybe it's
trying
under
to
the
think.
types. Oh, here. It's nope. It's not ECR. It's ECR. Nope. No public. Okay. So we have this now. Okay. So I bet this probably. Oh, yeah. Okay. So this failed. Oh yeah. Expected to be one of ECR public. Okay, great. Let's run this again. And yeah, hopefully after this. So in the first hour after this, assuming this all works, we'll move on to building our front end application. Oh, I guess one thing we didn't even talk about is like, okay, I do all this. Like, how do I get the value of this? Like, how do I know what the endpoint of the service is without actually like going to the console and stuff? And that, you can do that with exports in Pulumi. I think I might have showed that earlier with the bucket stuff, but we can do that for sure here. So you can do export, and we'll call this service, I don't know, endpoint. And we can just do the service URL. Maybe we'll match this name, so service URL. And so the next time we run an update on this, on the stack, this will come out as a stack output. And we're gonna actually need that later, assuming we get to the part where we try to combine these two applications. So while this updates, let's skip ahead to that. And so we'll go back to here. This is the Howdy Partner directory we were in earlier. And we'll make a front end. And we will Pulumi new AWS TypeScript. So now we're gonna, all the people who want a TypeScript, now is your moment. Let's see how this is. Okay, great. So this should be done. And actually, I can go to. Yeah,
so as you're doing this, let's just do a quick recap for people that might just be joining.
Oh yeah, sure, yeah.
Yeah, so we just created his backend service in Python. He created all his IAM roles. He defined his app runner service, and he pushed his image to ECR all within his backend code in Python. And so he just gave us an example of how you can do all that in Python and using Pulumi. And he made it a lot easier than I thought it was going to be. So this is a great start. And now Lee's working on the front end, which he's going to do in TypeScript and React. So with that said, let's see where we at. Yes.
Yeah, so I'm just going to finish updating this. But I guess like I think someone earlier was kind of asking like, oh, like what clicking to the console versus like doing this in code. Hopefully you can see like, yep, in the console, you could have done the console part was this part really. Right, that Young was showing, where we configured, some service in App Runner, and in the console it also, auto created this policy for you. But here, obviously, you have, full control over what policy you would want to create, and then also here, we're actually setting up that repository that holds the image, which you could do in the console as well, obviously, by clicking a bunch of stuff, but here this is a very programmatic approach, and we're also including this actual Docker build. Looks like something actually, I think I just saw something failed.
Well, I think the other thing I'll add too is, I think a classic example of that I initially think of is if you already have like a running database and you want to deploy an app runner service, you have the option in the console to pass environment variables to pass those connection strings to be able to connect the database. But if you do it with infrastructure as code, you have everything all defined in a single template or within a project directory. So you have everything in one place. So I guess like that's another trade-off is you kind of have the convenience, right?
Totally. And I you can see here, like we mess something up, it says, hey, authentication configuration is invalid. And I'm realizing here, we never use the role. And you kind of need that, right, to do that. So I'm setting that up now. So I saw there's a authentication for configuration parameter. I'm going to give it this access role, and we call this app runner role. And that's the on of that. So hopefully now this will work. and we'll just do, okay. So we're going to assume that works. And so, yeah, I'm going to go back to the, while this is running and getting the app runner service up and going, let's go back to our TypeScript example. And let's go to front end. Oh, I'm in the front end already. Let's just open a new code window for this. Is it? Okay, so we're going to get rid of this. And I don't know if we showed this before, actually. So we're going to try doing something here. So we're going to first, we're going to create a new React project. I don't know if create React app actually creates a new directory for you. I'm going to assume it does. Actually, I haven't run this in a long time, so we'll see what happens. Okay. We'll call this, I don't know, web app. See how this is doing. Oops. Okay, so now, yeah, now it is creating the service correctly. So we'll wait for that to finish. Okay, and this is installing all the dependencies. So, all right, now we're in a weird spot where I have to wait for stuff.
No worries. So while that's getting created, Young, who are we? What is the show, and why are we here?
We are AWS Howdy Partner, where we highlight some of the cool products or cool things that our partners are doing. Our AWS partners build on top of AWS to provide solutions, great solutions for our end user customers. Today we have on Lee from Pulumi for the third time. He wants to, well, we've so far talked about Pulumi 3.0 and some of the work that they have done with App Runner, which is a service that just came out hot off the press last week. I showed a little bit of demo on how to set up App Runner on our console, and Lee has just created a backend that served up a Flask app as a container image through App Runner, all using Pulumi infrastructure as code, using Python. And now we're here creating the front end using TypeScript.
Yeah, thanks for the summary. Let's see how this is all going. All right. Yeah, I think last time in the console, I guess when you showed it, I guess it takes a couple minutes for the service to actually come up, right? So I guess it's probably
it takes. Well, I didn't time it, but it takes quite a bit of time. So.
I guess we can actually go see if it's what's going on here. To your point, like we should see that there's So this is the example. I think I called it example. I shouldn't have named it that. Did I name it that? Did I really do that? I did. Okay. Well,
no worries.
It's called example now, and you can see it's in progress. But this is the backend app source that we hooked it up to. Let's see how far it's gotten. Okay, so it's going along. It's doing the health check. All right, so hopefully it'll come up any second now. Okay, so what I wanted to do here is to actually so let's go into web app. And yarn start, make sure this all works.
And the audience, if you have any questions, please let us know on the chat and we can get them to you.
Okay, great, so this works. So we actually don't need this. So we're gonna build the React app. That'll create a production build. And what we're going to do is we're going to take that production build and map it as a static kind of like path website. And we're going to do that via API gateway using TypeScript. So we will call this and the reason we would do that is because you can imagine like later on we could add things or change things up, or kind of like use that API gateway to front other things. But for now, we're just going to front our little simple web app here. You could also do this via S3. I guess we could show that as well. But either way, we're going to end up doing something to get the web app out there. So let's do, let's call this API. So AWS X, by the way, oops, I'm not in Python anymore. AWS X is a convenience library that sits on top of AWS library. So basically this is a kind of, this library, the AWS, Pulumi AWS library is a kind of like a close approximation of the actual service, one-to-one type stuff that you would expect to see in terms of like the AWS services, whereas AWS X kind of does a little bit of a higher level abstraction. So kind of like if you're familiar with CDK, similar to L3 constructs from a CDK perspective. So we're going to create an API. And we're going to give it these args. And you can see we want to give it some routes in this case. And I believe this takes an array. Yes, array of routes. And we're just going to give it one route, really, and it's going to be our web app route. So path. This should be /. And here we want to give local path. I think it's build. Yeah. I think this is everything it needs. I actually am not 100% sure, but let's try this. I guess someone earlier said just brute force everything, right? So that's let's just do that. But I think this is so. What I'm trying to do, by the way, is I'm trying to basically map this local path, which is this build we just did, which is our React app, and map it to the API gateway path of /. And then ideally we'll be able to access our web app via that. So if all goes well, that should work, and we'll see. Let's see how our other thing is doing here. Oh, great. So you can see we got the service URL. So we should be able to curl. We can actually, since it's a stack output, I can actually run man, I don't know, my machine is doing some really weird stuff, it seems. I can only assume. Or somehow this is timing out.
Yeah, I guess we can't really brute force this one.
Okay, well that's fast. So somehow this is slow. And I thought it's running on 5,000. I guess maybe let's go take a quick look at our backend here. That's the domain. Oh, I see. So the 5,000 is the port for the container, but okay. So but AppRunner actually just puts it on the port 80. Okay, so that explains why adding 5,000 here is not a correct thing to do. All right, great. So by the way, like this should be like a whoa moment. Because like, we did all this stuff and then, this just works, right? Like we built the app, we shoved it into ECR, we defined this app runner service, and then like we curled it and here it is. This is the app we built. And we did that all like in less than an hour. And you can imagine now you have this super, like to your point earlier, you have this super repeatable piece of infrastructure now. I can go modify this app, run Pulumi up, have my app deployed, change environments, create a prod stack, and then do all sorts of other stuff, and kind of have, I could stamp out hundreds of environments, or I could do whatever, right? And I can, I can do lots of things with the code here to kind of extend my solution. So great. So we have our backend, and let's see how our front end is doing. So you can see the front end here. Yeah, it's going to try to create all these bucket objects that represent the actual front end, and then also the API to the front end. So let's run the update on this. And hopefully at the end of this, we will have a front end application we can go use. And now comes the interesting part. So like, what we would really like to do is go into here. This is where actually like I haven't used React in a while. We would like to do some kind of like fetch, to fetch something from our backend. We want to do something with our backend. Let's see. I don't know. We'll just use Google. Fetch data React. This is where like. Okay, this sounds like a potentially good resource. Okay. Let's try this. Oh, but why is this in JS? Okay, I guess. Sure. So use effect. Okay, let's just try. Oops, where was the other thing? Oh, I don't actually have. Let's do this. I'm gonna assume this is actually gonna fail because of cores, but let's just try it. And let's see, what does this return? This returns like a promise, I assume. Yeah. Okay, let's just try this. Oh, okay. Well, that's not what I expected. React is not a function. What? Okay. Maybe this is not the right tutorial to look at. I mean, this looks like I'm doing more or less this. I should have made my React project in TypeScript. I feel like I would have better type information and not fail so hard.
No worries.
Okay, we have this function my component, use effect, fetch. Then I think this is literally what I'm doing. What does it not like? I'm gonna Google this error. Oh, I'm importing React twice. Did I miss an import earlier?
Someone in the chat, I think, is giving a suggestion.
Okay, great.
I think, yeah, maybe import user effect from React. I think that was a suggestion.
Destructuring.
Yeah.
Is that, I should be destructuring? But this is, am I not doing this? Let me just copy and paste this and see if it, oh, I see. Sorry, they meant I should be destructuring like this. Okay.
Yeah.
That makes sense. Yes, because this is a thing within, yeah. I don't know why, I don't know what I'm thinking. Yes, obviously. Okay, great.
Oh,
Thank you.
There you
Okay, great. And this failed because I'm guessing should be because of cores, I would assume. Yeah, cores. Okay, great. So that's actually what we kind of want, in the sense that like it shouldn't work. We will fix that. I think we can fix that by returning the right cores headers from the backend, and then we will be able to then make this work. So I actually have not. I in principle know that that's how this should work. I have not actually like I said, this is literally live coding, so I haven't actually verified any of this beforehand.
go. And that's
But
how
we're
you
about to
know
find out.
this is for real.
So, anyways, what I forgot to do is I would like to export the URL. So we need to export the URL of the API. Oops. All right, so while that runs, let's learn how to do Flask cores. I did bother to look up like the Flask stuff earlier, but I guess I should have done this too as well. Okay. Okay, blah, blah, blah. Okay, great. Install Flask cores. That sounds easy. Let's do that in our backend. Let's just go see what versions are out there. .3.0. Okay. And we just do this. Okay. Wow, is it really so simple? Okay. Now, I've never actually done this with Flask before, so that's pretty cool. So this will actually rebuild our app and deploy it. And hopefully we see this course thing work. Okay. And then later what we could probably try to do is, incorporate some of this stuff, but for now, we don't have to worry about that. Okay, and then the other thing I want to do is get this. This is the front end. And, okay, yes. This did not work, I think, because we have this /stage thing here. And I think React expects this to be the root, I think, or something like that. That's what I remember last time I played with React. So I think what we have to do is change. There is something in here. I'm just going to Google this as well. I think it's called like React Home, or I don't know, home directory or base directory, something along those lines. Yeah. And I think it needs to have a specific, you have to pass in something somewhere. This does not look right. So I'm just trying to remember how, oh, here, homepage. I think this is it. What? Oh, here. Oh, okay.
That's
very frustrating. Okay, I'm gonna assume I can just do what that kind of said, which is set homepage to /stage, and hope this works. Okay. Maybe I should read this link. This looks like, maybe this will tell me what homepage does. Oh, here, yes. Oh, does it have to be a fully qualified URL? Okay, not clear, I guess. I guess we will find out. We will find out in 1 sec. So it updated this. Okay, it worked. Oh, great. Okay,
wow.
So you can give it a relative. For those who are wondering, based on our brute force experiment, you can give it a relative URL and it'll work. So even though the documentation doesn't say so, you can trust us. We did it. All right. So great. So now I think the only thing that's, and you can see actually the course response worked because we actually deployed our. Let me just refresh this. You can see here when it calls our backend, it actually did get the response "Hello World." So we have our front end and we have our back end running, which is pretty cool actually. And obviously, like, this is all a toy example. Like, we would actually be doing something with this fetch. Like, you would use it in the application somehow, and then similarly, with our back end, you would actually be doing something like, more meaningful than returning "Hello World." You'd probably, like, going back to the question earlier about, hey, why infrastructure as code? Why not just configure this in the console? You probably have something in here that defines your database or some other set of data stores, and then kind of more and more of your infrastructure. And as your infrastructure grows, you're going to define more and more things, and then that way you can stand up dev stacks or even individual stacks. Actually, at Pulumi, we run a SaaS. That's everything that kind of we were showing earlier, by the way, in the Pulumi console. Like, this is our Pulumi console. This is actually built on, we use Pulumi itself to deploy this web application. And every developer on that team has their own personal dev stack, but it all executes against the same program. It's the same program that deploys the dev stack that deploys our production stack. And so we have a lot of confidence in that the infrastructure is exactly the same between any developer's individual stack to our testing stack, to our staging stack, to our actual production stack. It literally all looks the same. Well, not quite. It's literally the same program. Right. Where it's sometimes different is the configuration being passed in. Like on our dev stacks, we aren't using the same high cost database instances or the same high cost EC2 instances or whatever it is. We're using like lower cost ones or fewer or whatever it is, but kind of it's the same program ultimately being executed in either case. Anyhow, cool. So we actually got through. Let's see. So what do we say we were going to do? We were going to get a Pulumi project going. We got 2 of those going. We had the front end and back end. We built the back end with an app runner service, and we used Python Flask, and we got cores going for that. We're going to build a front end, which we also did using TypeScript and React. And actually, like, by the way, the TypeScript we ended up using for this was like 5 lines, but it really shows you the power of abstractions and Pulumi, where we're using this kind of pre-built higher level component called AWS X, which has a thing in here called API. It lets us map a local path, which is our built web application, to a path on the API gateway, which is which was slash here. Stages, because API Gateway has multiple stages. This is the default stage in API. And so, we got this URL, and that's where our deployed web application lives. So now we have both sets of things done, actually. And so now what we have to do next is we would actually like to connect these two things. We connected these two things together via, like, I just hard coded, I think, in my application. This here. Oh, sorry, I'm in the wrong app. Where am I? Let me close all this. Here we hard coded this. And so we could, you could imagine, like, pass in a build parameter that uses the Pulumi stack output that I showed earlier to stick this in. I'm going to kind of skip over that part. Oh, should I? Okay. Well, it's okay. Now comes the interesting part. We're going to do automation API to try to tie these things together. And maybe if I'm good enough, which I'm probably not, because we only have 30 minutes left, but I will hopefully try to tie everything together in a meaningful way. So let's do that. So let's make a new directory and call it automation, actually. And here I'm going to go crib more code, because that's really what I'm good at. And there's a great repo called Pulumi Automation API Examples. And here we have a lot of examples on how to use this automation API thing I talked about earlier. This is one of the things we GA'd in Pulumi 3.0. And so we'll use some node examples. Oops, I clicked the wrong button. We'll use some node examples. And what we want to do is we want to use a local program. So we have these local programs. We're going to coordinate these programs. So you can see, like, this looks pretty similar. Okay, so let's take automation. Okay, so this is what we want. So we can actually, let's do this. We're going to copy this package JSON, stick it here. Okay, this all looks correct, except for this. All right, we're gonna, Evan should get credit. By the way, Evan's an awesome developer on the team. We're gonna delete his name from this package because I'm writing it now. And I know this is pretty cruel, right? No, but so we're gonna take this. We're gonna take this and copy some of this here. We're gonna copy pasta our way to success. Okay, so what are we trying to do? What is happening in this, I guess, is maybe worth talking about. Automation API, like I talked about earlier, lets us use Pulumi in a way that, like earlier, everything you've seen me do so far has been like invoking Pulumi up, right? And running the Pulumi CLI. Automation API lets us run Pulumi without having to invoke the CLI. Lets us use it programmatically. So that's what these local program things are. So actually, let me pop open this. Install the dependencies. And so let me actually see what this example does. This example creates a stack using a local program. In this case, it's using the website directory. Our case, we're going to say front end, right? And it's going to have a stack name. In our case, it's dev, which is correct. We defaulted to dev as well. And we're going to create or select that stack. So that's good. So, and then we're going to set config. So you can see, you can, just like in Pulumi, you can set config. We're going to set config here. We're going to skip the refresh. And we're also going to, we're not going to destroy our stack. So we're not going to even have, this is a command line option thing about like this. We're just going to skip all this. We're going to simplify the code here. We don't care about this. And we're going to update the stack. So that's all good. I don't think process actually ever gets used, so we can delete all that. And I think, great. So this automation API program at this point, like what you have here, this will basically execute the local program that's in the front end directory, and it will do the equivalent of Pulumi up. That's what this line here is, and it'll programmatically execute Pulumi up, and then you can actually see the update summary, and you can actually see actually here we're going to change this. The output name, as we recall from earlier, was API URL. And so let's try running this. So the way to run this is not Pulumi up, but there's a handy dandy script here that's just going to execute TS node for us. And so we're going to run yarn start. And hopefully this works, because I haven't tried this before. Okay, but you can see again, so this is working. And now it's trying to run the update for my stack that we defined earlier. Okay, like that seems, well, what was the point of that? That's the same thing, right? But now we can start to do some coordination between the stacks. So for example, you could imagine, or not imagine, we're just going to do it. You could also add in the other stack. And so here we had, we should call this like front end args. And we'll start refactoring some of this real quick. And we could also copy and paste. Again, I'm really good at copy and pasting stuff. So we're going to copy and paste this, and we're going to do backend args, right? And we're going to bring up our backend too. Okay, so now we have and we have two different stacks, right? So we have our backend stack, and we have our front end stack. Okay, and now backend stack, front end stack, okay, great. And then now we can actually, oops, this is here. We'll set both configs. So, but here's something cool, right? Like before, you would independently control these two configuration values, right? Earlier, as we talked about earlier, like I would go into the backend and then set the config here to US West 2. And here I would set the config in my front end app to US West 2. And like those are just handled independently. And, like very easy to, well, not easy, but like you could totally imagine someone like myself who loves copy and paste screwing up and coming in here and then being like, oh yeah, blah, blah, blah. And then like, now this is US West 1 or something. And now my two stacks are in like not even the same region. But because we're using Automation API, we could say like this. Right? Oops, why did I do that? And now they're guaranteed to be the same region. Right? Because they have to be, because that's how the code works. And you could also imagine now, every time we can make our program such that every time I deploy the front-end stack, I also deploy the back-end stack. Oh man, okay. I don't know why I went too refactor happy here. Okay, and we could do the same thing here, like update summary, front end update summary, back end update summary. And so now we're doing this interesting coordination between these two stacks, right? So now we're deploying the back end and the front end at the same time. Hopefully, actually, this is where I like shouldn't do too much kind of like renaming of stuff, but I think I got all the names right. And so, okay, updating the front end, and then after this, it'll update the back end. The other thing I guess that's probably worth thinking about now is like, okay, in our cores configuration earlier, maybe we could start thinking about interesting stuff like this. Where was it? Here. We kind of allow cores for anywhere. And maybe we don't want that. Like maybe we don't want anyone to be able to access our backend from a cores perspective. We want to kind of be like more cores locked down because most browsers respect cores. So if I go back to this, there was this like origins option. And you could imagine let's see, we would have to, okay, this is going to be a little complicated. So I think we have to thread a few things through this, but let's see. Let me get the other thing to work first. But like, let me describe what I want to do. Sorry, that make brains all over the place. What you could do is you could have you could copy. Let me copy and paste this first. You could change this to be like this, and this would be slash, and then origins would be some environment variable. Well, cores domain, right? And then you could change this to, I think you could pass environment variables in, right? Like here's the image configuration. I believe here you can pass in runtime environment variables. And what does this take? This takes, oh, this takes a map. Okay, so you could do course config or course domain. And this you could then plumb through to be Pulumi config. And so here we have Pulumi, and so we could do right? And then you could do this. Okay. Actually, don't have this. I'm actually kind of just going through with this now, by the way. Like I'm not even just, I'm just doing the idea. I was going to start to describe the idea. I'm starting to do it. Hopefully people can kind of see what I'm trying to do here, where we're going to then, in our automation API program, we're going to set the config for cores domain to now be the value of the front end URL. And we know what that is, right? Because we have this. And so actually we can do this, we actually have to do this after this is done. So we need to go here. Oops, yeah. Outputs.api URL, right? Is this right? Oh no, I had that right. Yeah, value. Okay. Oops. Yeah, so I don't think this is quite right because I need to modify this value. By the way, another cool use of Pulumi is that you can just like use whatever programming language constructs you want. So I think I would have to, let me not do this yet. By the way, this all worked. You can see this did all the updates and stuff. And it deployed both our stacks together for those following along. We modified our automation API to program to deploy the front-end stack and the back-end stack together using the same config. But what I'm doing right now is I'm trying to now connect the two stacks in a more meaningful way. Like they deploy together, they use the same config, but wouldn't it be cool if you use the result of one stack in the other as part of your deployment? Because like the other way to do this, by the way, is with the stack reference. So I'm kind of going to all this trouble using automation API to do it. Like there's actually a much, in this case, you don't have to do this dance that I'm doing right now. But I think there's like a kind of a good reason in some sense of like why you might want to do this. So let me show you this. Let me show one last thing and then I'll shut up because then I'm guessing you guys have lots of questions. And you're just like, what the hell's going on? So one last thing you could do is instead of doing this in Python now, you could do stack reference, and we would reference the name of the stack. And so in this case, it would be I think the name of the project was like backend, and it would be it's a fully qualified stack name, so it would be backend, and then it would be like Right, so this way, get stack here is going to return dev, and that way it'll match. It'll be the same environment front end. And I could do something like this, and I could get the output of the API URL, and then I could use that API URL. It'd be the same idea as this, where I can use that cores domain for the API URL I get from that front end stack, and then plummet through to the cores configuration in my app. Same idea. The reason you might not want to do this is because in some cases, when you're setting this up initially, if you think about it, you kind of have like an initial chicken and egg problem. Like, we glossed over that chicken and egg problem because in my front end, I had hard coded this, but this is not what you would actually do, right? In reality, you would also here, you would fetch from, some environment variable, most likely like process and, API URL, right? Blah, blah, blah. So, do the same thing here, but like do this, right? But the thing is, like, this API URL doesn't exist until you deploy the backend stack, but the backend stack can't configure cores until you deploy the front end to know what the front end's URL is. So you're kind of like stuck. Like, how do I like break this tie, or how do I break the cyclical dependency? And the way you could do that, this is the full circle of what I'm trying to explain now, is in Automation API, because you could initially deploy it where the config here, when we do this first update, we could set the config to be like empty. Like we don't even set the config. We just say like, okay, you're not gonna have a URL, and then later you can then nothing stops you from re-invoking the update with additional config. So you would first deploy the backend with, you could choose either one to be the first, but you could imagine deploying let's say the front end with no backend URL, so the front end is effectively not working. Then now you have the front end URL. Then you deploy the backend with the front end URL, and then you redeploy. I guess okay, so I wrote this wrong. You redeploy the front end. This time passing in the backend URL you got back from the backend deployment, and then now you've solved the chicken and egg problem by coordinating these 3 deployments in a row. Anyway, so I'll stop there and see if that made sense at all, and if anything I've done so far, you're just like, what is going on?
Well, the chat's quiet, so I can assume that's a good thing.
All right, let's see if we can answer some questions here from the chat. Yeah, okay, so super helpful, by the way. Thanks. Going back like almost 30 minutes ago, Callas, for the destructuring of use effect. Totally forgot about that. I don't know why I forgot. Okay, is this like waypoint? Not really. Like Automation API is, I would say, more general, asking about Automation API. So Automation API is more general than waypoint. Like waypoint, I think, in my opinion, is more of an opinionated way for application development, application deployment and development. Here, we're trying to take kind of the idea of using Pulumi infrastructure as code and kind of all the primitives you would have that you would expect to use with the CLI, but turning it into a programmatic interface such that you can do the kinds of things I just described, where you can kind of coordinate different stacks, coordinate deployments, break cyclical dependencies, do multiple deployments in one go, and even do multiple deployments of the same stack in a coordinated way. And then again, because it's programmatic, using the outputs too. Like, you could try to do a bunch of bash scripting on top of the Pulumi CLI, but here, these resource changes, this is an actual structure, right? And it's an actual thing you can go inspect with your programming language. And same thing with these outputs. So these are all kind of like typed objects you can go use to then decide what to do. For example, right now I'm not doing anything fancy here, but like you could do error handling, like, oh, what happens if the stack update fails, or what happens if there are no resource changes, or whatever it is. You can react to how your infrastructure is changing within your program.
Oh, actually, Lee,
yeah.
you brought up a really important point. We talked about this the last time you were on the show, but I think it's important for folks that are looking to adopt infrastructure as code best practices to understand drift detection. And I think that's something Pulumi does really, really well under the hood. Could you maybe talk about a little bit about how that works with Pulumi?
Sure, yeah. I maybe just, easiest maybe to show an example. So one of the things you can do in Pulumi is you can run Pulumi refresh, which tries to refresh the state of all the resources. So let's run it here, I guess. Where am I? From the backend? Okay. There's fewer resources here. Let's do it in the front end. And what this is going to do, what Pulumi refresh does, so actually maybe let me briefly describe how Pulumi works, because we didn't talk too much about that. Pulumi, manages state. And so we keep state of like what we think exists. And so let me do yes for the initial refresh. So this, you can see here, these are all the objects that Pulumi is tracking from a state perspective. And so this is the role for the API gateway. These are all the S3 buckets and bucket objects that got created as part of doing that mapping I talked about earlier. This is all the stuff that this is the gateway, deployment. This is all those things. So run Pulumi refresh one more time, I should see no diffs. So what refresh does is it goes into the state and says, okay, what are all the resources you have? Let me go read the current state of all the resources. So you can see, based on the current state, nothing has changed. Okay, great. What we can then go do is let's go mess around and, okay, what was the, okay, we have an API gateway deployment. So I don't know, let's try to like mess around with some stuff here. We have front end, and maybe let's change this to we can change this to do something else, maybe like, how do I actually, it's funny, I don't use the console that often. Okay, let's do this. Let's just do like, instead of AWS service, it would be like mock or something. It's gonna let me do this. Okay, sure. Okay, so now I've changed my actual setup. And you can see this is now mock. It doesn't point at S3 anymore. So if we do Pulumi refresh, then we're going to go back and try to reread all those resources. One of them being that API gateway REST API, and hopefully one of them should show. Oh no, it didn't. Well, that's not good. I wonder if this is not. Oh, but this is not. This is not modeled as a resource. Okay, let me do something that's more obvious. Let me go delete manifest.json. Okay, sorry, this is not a good demo. Let me go to the resources here. And okay, do this. Okay, so let's just delete this object. Okay, so we deleted that. And hopefully now, now that we could also change some of the properties on that object, by the way. Like maybe we'll do that for a different one. Let's go change like the properties on fave ICO. But what's going to happen is when we do that read, we should detect. You can see like it actually says, hey, there's one that's not there anymore. It wants to delete it from state because it's no longer, when we try to do the read, it's no longer there. And similarly, if I go change some property of this, for example, let's see if I can do anything useful. Let's add some tags, for example. Oops. I think this should work. Oops. Similarly, if we run refresh here, it should also notice that, hey, for this object, there's a difference in the actual properties of that object, and so it'll detect that there's you can see one to update, and that one to update, if we go into details, is that there's tags. So that's kind of how the drift detection works. Is if you go change a bunch of stuff without changing your program, then there'll be drift between what state we have stored in Pulumi versus what's actually out in the cloud.
And so this is important, right? Because if you have like a large organization, you have multiple teams or multiple developers working on the same code base, if you will, you want everyone to be on the same page. So if there's like a ton of drift between what everyone's working on, it's just going to cause nightmares left and right. And so that's why the concept of drift detection is really important for infrastructure as code. Because again, like for all the teams and different developers that you may have working on a project, like you want everyone to be on the same page. And so if something changes, like your developers and your different teams like need to know what those changes are, right? So again, like I think this is really important for people that are looking to adopt infrastructure as code, whether it's Pulumi, whether it's another provider. I think it's a really important topic.
Yes, I'm just going to re-update. I accept those changes basically. I said, okay, I accept that this drift happened, and I'm going to run Pulumi up again, and that should go and recreate, because my code never defines this object being deleted, and my code never defines this having a tag. So now it's going to go and try to it's going to go create that file again because we actually need it, and it's going to go update this to remove the tags that shouldn't be there. And so if I do that, then things will be back to the way they should have been. I'm also realizing now, I think I know why the API gateway thing didn't show up, because we didn't deploy that change.
True. Yep.
So so there's no actual resource change there. Like it's only if we had deployed the change that we would have detected the change. So actually, if I go to like the deployed version of the service, oops. I'm guessing it's still like correct. Yeah, and this I think we never deployed this, right? So this is still pointing at the correct, like this is still pointing at the S3 bucket.
All right.
Yep. Cool. Let's see. We have a few minutes left. I guess we could try to finish plugging that thing through. So what was I? Or let's see if there's any other questions. People are asking, are static website assets for create React app being served up by API gateway? And yeah, actually, oh, sorry, Young, you already answered this. Yeah, it was by S3. And actually, we just showed that actually how it's using the S3 integration with API gateway. So what's happening there? Cool. I actually don't know if I'm going to be able to get this work, but let's try it. So okay, what were we doing? We were trying to in here. Let's go back to this hard-coded thing for now. So in here, we were trying to use this. This should get the environment variable cores domain. Okay, I remember now. So we need to actually, in our, where's my automation program? Here we go. Here, we need to, when we set this config, need to strip this URL so that it's just I think the way cores domains works is it should just be the domain name and not anything else. Let me just check if that's true. Yeah, because I think the allowed origin. Oh, I see. Okay, so it's everything up until before the first slash. Okay, so let's see. Actually, don't know how to do this the best in Node. I think like there's some built-in URL parse. Yeah. Okay. That's what we want. It is indeed. Okay, so let's do that. Okay, and then we should be able to do here. Oh, I don't have even, okay. Oh, and that's right. Okay, I think that's what I want. So, yes. Okay, so now what we're trying to do here is basically parse out the origin from the front end URL, pass it through to the backend stack as the cores domain config, and then on the backend stack side, we're actually just reading that in, and this is coming in via via the environment variable cores domain. And this cores domain is being fed into the environment variable via our config, which is named cores domain. So this should, in principle, work. We're about to find out. We're going to go back to Howdy Partner, and we're going to run yarn start. So yeah, I'm not going to finish, I think, in the remaining 7 minutes, but like you can see how then you can do the reverse of what I was talking about, where we then do the front end URL and pass that, sorry, the back end URL and pass that through to the front end, and then do an additional update to kind of like finish that full coordination. And then you've broken that chicken and egg problem that I was talking about earlier. Okay, and you can see here, we can see there's a diff in the source configuration, which should be the environment variable that we pass in. So actually, if we go check the app runner console, hopefully we see that show up there. No? Let's see. Oh, how come it doesn't, environment variables don't show up there?
I think it might still be deploying. I think that might be the.
Okay, I guess it's still updating.
Yeah.
Yeah, I guess I was surprised. I guess like there's no here. There's no environment variables. I guess I don't know where those show up in the console actually.
It could because it's still updating the service. So you may have to refresh the page. Yeah.
Maybe is it somehow no. I was just curious, like if I wanted to set the, even if I wanted to set the environment variables myself, like via the console, it seems like I have no. Can I do that?
You definitely should be able to. Like, or you know what? Let me look at the docs now.
That's okay. I was more just like kind of curious, like, oh, like that's interesting actually. Like, I don't see a way to do that actually.
You should be able to.
Yeah. Okay.
Huh.
Cool.
Under configuration, but I don't see it on this screen.
Yeah, I couldn't find it. So
under service
I
settings,
wanted to make sure it actually passed it through somehow, but interesting. But well, I guess it's worth mentioning that like I go to our console, the Pulumi console, and you can see that as part of this current deployment, the configuration value that's getting passed in is the API gateway origin that we expect.
Right.
And so assuming my code is good, then what should happen is, because this configuration is defined here, this gets picked up here, this CORS domain is then passed in through to here as a runtime environment variable, which is CORS domain, and then hopefully I also wrote good code here because we didn't test any of this, but like here, hopefully, when we set up CORS on this app, here we use this. I think it's called. Oh, actually, this might not be OS. Okay, it's not good code. It should be OS environ.get. Okay, so we're definitely not going to finish because the deployment itself we know takes a couple minutes on App Runner. But if I had done this correctly, I should have remembered how os.environment works in Python. But had it done this correctly, then this would have that value that's piped in all the way from the other stack. And now our origins would be restricted only to that API gateway front end, and no other origins would access our backend as far as cross-origin requests go from a browser perspective. So yeah, I think we'll stop there since I don't want to redeploy the service at this point with 1 minute left.
No worries. I think this is really helpful for people to understand the power of infrastructure as code, because like we just tried to see in the console, we can't actually see the environment variables just yet. But because you're defining everything in code, you have a lot more granularity as to kind of what is going on with your application. But Lee, for people that want to learn more about Pulumi or want to get started with Pulumi, what would you recommend to get started?
Yeah, I think the easiest way to get started, you go to pulumi.com and we have a big get started button, and you choose AWS, and we walk you through everything about how to get started on AWS, walking you through how to install Pulumi, installing the language of your choice, and then getting everything set up and configured so you can actually use Pulumi with AWS, and kind of walk you through a very simple initial example of how to actually use, build a program in Pulumi with AWS. So yeah, that's definitely the easiest way to get started. And then also as part of that, you'll end up getting signed up for the service, and you'll be able to, start doing a lot of the stuff I was showing you today.
Sounds good. Other than that, Lee, thank you so much for coming on the show and, having the courage to do a third live coding session.
Sure, of course. Yeah, this was fun.
There's not a lot of people that are willing to do that. So we really appreciate your time. And I know I definitely learned a lot because my friend skills are almost non-existent. So I definitely learned a lot from the session. So I really hope everyone else that joined today learned a lot as well. But other than that, Lee, thanks so much. Really appreciate it.
Yeah, thanks again for having me. This was super fun. Hope people enjoyed, going through the various, back end, front end connections and kind of getting everything hooked up and kind of seeing how, infrastructure as code is super powerful and, really practical too, in terms of helping you wire together your applications and your projects together.
So, Young, are we forgetting anything?
Just to say that next Wednesday, join us for another episode of Howdy Partner. Next week, we'll be back at 2 p.m. Pacific time.
All right,
I think
thanks, everyone.
I remember last time I was on. Don't we have like isn't there like a Howdy Partner sign off? Like,
oh yeah, that's right.
You're totally right. You're totally right.
I was so engaged in this session that I kind of forgot about it. But let me just say, to end our Howdy Partner episodes, we have the 3 phrases. So I mean, you as the guest get to choose one. Hopefully something different from last time, but the choices
I can't remember what I chose last time, so I'm so excited.
Oh, okay. Well, I guess it's just all random at this point then. We have giddy up, happy trails, and see y'all next time. So those are your 3 choices, and
let's do see y'all next time.
All right, sounds good. So on a count of, I guess 1, 2, 3, or 3, 2, 1, we'll say see y'all next time. So 3, 2, 1.
See y'all
next time.
All right, we kind of butchered that, but that's all right. Thanks everyone for tuning in. Join us next week, 2 o'clock Pacific. We're here every Wednesday at 2 o'clock, so make sure to join next week. Thanks.
Thank you. Take care.